84.827 times 10 to 1. So therefore, stress max for AC is less than stress allowable. Okay, so our structure is what? So the structure of member AC will not fail. Or yeah, will not yield, not fail. Okay, yield. That's the difference. Okay, yield means it's going to have plastic deformation. So for this case, we know that it will not. Okay. So the next thing we are going to look at failure mode. Number 2. Okay, so failure mode number 2, as we mentioned over here, right, is stress BC must be less than what? Stress U divided by 1.4. So stress BC must be less than stress U, right, divided by factor of safety. Okay, so we have to calculate our stress allowable, which is equal to what was it? Is equal to we were given that is equal to 300 times 10 to the power 6. Okay, 300 times 10 to the power 6 divide by 1.5. That is our factor of safety. Okay, so 300 power 6 divided by 1.5 is equal to 200 times 10 to the power 6 Pascal. So stress max of member BC. So the load of FBC is equal to so FBC is equal to 333.333. Okay, so 333. So 333.333 times 10 to the power 3 divided by the cross-sectional area. We are given the cross-sectional area is 0.1 times by 0.1. It's a rectangular square. So 333.333 power 3 divided by 0.1 divided by 0.1 is equal to 33.333 times by 10 to the power 6 Pascal. So again, we found out that the stress allowable, right? The stress allowable or the stress stress max BC is less than the stress allowable. Okay, so material or member BC will not yield. Okay, so all these are straightforward. So the final one, which we have learned today, is our buckling analysis. Okay, our buckling analysis. So we know that the factor of safety is equal to PCR over P, right? We know that our P is equal to, so the load that's applying on member BC is FBC. Okay, so we know that this is FBC. And we know that FBC is equal to 333.333 times 10 to the power 3 Newton. Okay, so now we have to determine, okay, before we can determine, we have to make sure that the factor of safety that we are going to calculate is greater than 2.0. Okay, then structure, when this is the case, then the structure will not fail by, okay, will not fail by buckling. So we are going to calculate our PCR, which is equal to pi squared E, and then we are given I. Okay, we are not given I, we have to calculate that, and divide by LE squared. Okay, where LE is the what? Equivalent length. Okay, now let's look at LE. Okay, so I'm going to copy and paste this figure. Okay, and if you look at member BC, they are pin at this end and pin at the other end. Okay, so therefore, right, therefore LE is equal to what? So if both are pin, so we look at our table. Where is both are pin? Both ends are pin. So LE is equal to what? L. Okay, so when both ends are pin, right, we declare that LE is equal to L, and the L is equal to 4 meters. Okay, now we know that. So now we calculate our critical load, where at the boundary where onset of buckling will occur. We know that this is pi squared. Young's modulus is equal to, what was it? 200 times 10 to the power 9. Okay, our I, because it's rectangular, okay, so it's equal to BD cubed over 12. So because it's a square, is 0.1 power 4 divided by 12. Okay, I'll write this out properly. So 0.1 power 4 divided by 12, right? So this is pi Young's modulus I, and the length is our what? 4 squared. So the critical load now become pi squared times by 200 power 9 times by 0.1 power 4 divided by 4 divided by 4 divided by 12 is equal to 1028 or 1.028 or 28 times 10 to the power 6 Newton. Okay. So now we calculate our factor of safety, which is PCR over P. So this is 1.028 times 10 to the power 6 divided by 333.333 times 10 to the power 3. So this will be equal to divide by 333.333 power 3 is equal to 3.084. So we have calculated that the factor of safety, which is equal to 3.084, which is greater or greater than 2.0, right? So therefore, structure or BC will not fail, okay, due to buckling. Okay, I'm going to stop there. And as I said, on Thursday, I will do 2 more examples, long examples, okay? And we are going to eccentric buckling, and then you can do your, in fact, now you can already start doing your homework. If that's the case, thank you for your time and thank you for your attention. I'll still be online if you have any question to ask me, okay?